So I am here today to tell you that most likely everyone here has been doing tracing wrong. And there actually is a better way to do it. And tracing is, believe it or not, the actual future of observability. So that is me. I work at Omnition. I'm a software engineer working on tracing, open telemetry, which we'll get to a little later. But what really actually got me passionate about observability is actually my time at Lyft. So I am one of the original maintainers and contributors to Envoy alongside Matt. And the benefit of this is that it gave me a lot of experience in terms of operating microservices and teaching other engineers how to operate them. I was on call for Envoy and other services at Lyft, and on-call sucks, like most of you probably know. Right? It's always a mad dash in terms of trying to identify where the errors are coming from, what could be causing it, and it is definitely very frustrating. I have been woken up many times at 3 o'clock in the morning being very confused in terms of what to do. One other aspect that I was mentioning was me empowering other engineers. I don't know if anyone's looked at the Envoy code base or the documentation. It's great reference documentation, but it's not the best in terms of user friendliness because there's just a lot of features and it does get overwhelming really quickly. And so I spent a lot of time translating it into what I like to say human. I would teach others in terms of how to connect upstream metrics to downstream, in terms of how we did configuration. And it was great because a lot of our engineers were able to figure out what these things meant, but it wasn't intuitive. And so actually what I'm going to show you today would have made my life at Lyft a lot easier because instead of me explaining to people, if you follow this metric hop to another hop, to another hop, to another hop, that's how you figure out where the error came from. There's actually a visual way to show you all of this using trace data. And we'll actually only look at traces 3 times throughout this entire thing, so you'll actually forget we're doing tracing at all. Microservices are great, right? They allow us to deploy code independently of other things. So instead of having one deploy schedule maybe once a week, you can deploy your own component whenever you feel like it. You can use whatever technology. There's a lot of flexibility, and it's really powerful for engineers and applications to quickly develop. The downside is that things start looking like this. I wish I could use yesterday's slide in terms of what it was at the keynote, in terms of a really nice graphic of what looks like stars and all connected. It does get that messy really quickly. And so as great as it is to be developing on this, it gets really hard to actually debug. And so some of the main 3 points that we're trying to solve with tracing is the following. How do you actually know if you have a metric that's saying, I have this error, how do I actually know that whatever example of a log or trace is actually correlated to that? Metrics are great, but you don't have the context. Who to wake up? So say now you're all using Envoy, so you at least have consistent metrics. But then errors propagate across the system. So how do you know what's the difference between a service propagating that error and actually being the one that originates the error? And then what is the customer impact? How do you actually determine if the change you want to make at 2 o'clock in the morning is worth it? Do you actually make the risky change if it's for something that's used maybe once every 3 days? Or do you risk making something that will fix a bug right away that's impacting 90% of your customers? And a lot of things right now in terms of observability, unless you've done it manually yourself, won't tell you this. So right now, most of you probably are using metrics and logs. They're great. They've gotten us this far. And as I was saying, is that they're missing the context. Metrics is giving you one data point in time. Same thing with logs, right? Logs can be very rich for that one instance of a service. But then how do you connect them across multiple services in the microservice world? You can maybe have a request ID and follow those through. But with both of these, you are missing the context across a very complicated system. So how do we handle tracing? Well, this is how we're doing tracing now. One is that we pre-aggregate the data. What this really means is that we're going to be generating some metrics off, some SLIs or metrics off of the traces. But what ends up happening is that once you've created this data, and also traces usually tend to be sampled, once you get rid of most of the traces that actually create this, you can't pivot on the data in any different way. So you're really stuck with one way of measuring your traces. Most people who've ever interacted with traces Actually, probably, maybe most of you haven't, right? Because tracing is usually viewed as you look at one example. So you always look at like, oh, I know I have an error in the service. Maybe I'll pull up a trace today instead of a log. And so you'll see it in terms of what the entire call stack is for the service or through the application. But it only gives you a lot of data points, but doesn't really help you find out in terms of where to look at. And the next thing is sampling. Tracing, we usually only maybe keep point something percent, 1%, 2%. And if you use tracing, similar to if you use logs, usually the one you want is the one you didn't capture. So there's a better way. We're going to kind of dorkily call it the Omnition way of doing it. And so to all those 3 points I made, there is a much better way to do tracing. So one, instead of sampling, there is an actual way for you to capture all your traces and store them. Right? No longer do you actually have to generate them and choose which ones to drop. Most of the actual burden and the cost comes from creating it on the application side. The cost in terms of storage and transferring it is actually not as bad as people think it is. Instead of doing the pre-aggregation, if you determine later on in terms of how you want to group the data, now you actually don't have such rigid things in terms of like, oh, I looked at only these type of aggregated data, but I want to look in a different way. Since you have all your traces, you can actually go back and look at everything on a different pivot. And no longer actually looking at it as a funnel. If you look at all your tracing, if you have all of your traces for an entire application, you can actually visually represent what a service looks like, what the application looks like in terms of the service dependencies. So no longer do you actually have to look at metrics in terms of this is an upstream request to another one to another one. You can see things really nicely. So what do I mean? This is a happy application. All of this is a visual representation. It's a demo application, but it is actual visual representation of a live application using tracing data. There are no forms of building metrics in terms of say if we're using Envoy, in terms of what the upstream metrics are. Once you look at a trace, you know who you're talking to, and you can build this here. So now in terms of whenever you're onboarding new people, you don't actually have to say like, hey, like last week we called service A, B, C, and you make sure the APIs can change. You can actually just look at this here and say, okay, well now I'm calling service B, I'm calling checkout, currency service, and this shows you up to date. So in terms of whenever applications change, microservice dependency change, because as soon as you get into microservice world, it's really fun to change things and change where the APIs are going to. Whatever static list you maintain will be out of date within days or weeks. So kind of like what pages like to do. Errors are going to start happening. Oh, that's a little fast, right? So we have all these services that like to page themselves. And in a legacy system, or I'm going to call it a legacy way of doing observability, these errors right now are being paged based off of the success rate. So that's what this error red box is here. And so this is what a service is seeing in terms of errors. So upstream request 5xx. The thing about that is that we actually don't know which one's causing it. So we would be paging all 4 of these service team owners to investigate. Now, before we get to how to make that better, let's actually look at a trace. This is a typical view of a trace. It goes across several services. And what's really unique about a trace is that you can actually pinpoint when an error started. So instead of actually saying all these shaded red here, all of these services are paging, since you know that at the bottom with the currency service, the get conversion is the first one to actually throw an error, you can differentiate between a root cause and the actual ones that are propagating errors. So when it comes to paging, you can say, I'm only going to page currency service and let everyone else sleep. So let's look at that again. So here's where we actually calculate the root cause, or the root cause in terms of currency service causing the errors. So we're going to stop paging on errors, and we're going to start looking at root cause. Now this actually helps us identify who to wake up in the middle of the night, and also just who to page whenever. This is something that is unique to tracing. Metrics, unfortunately, doesn't give you the context you need to determine this, unless maybe you added some headers and did some special processing on top of it. Kind of ugly, but tracing is unique to this. You can't do this right now with logs or metrics. So, now that we know that the currency service is paging, we're going to debug it. What could be causing the issue? In terms of whenever I'm debugging, I usually try to come up with a hypothesis. Right now, I see that get conversion path is returning errors. My first guess is going to be like, maybe someone messed up that API. So, right, that's what I'm going to guess. And I'm going to look for another instance of get conversion API and see if there are any errors. Well, this one, unfortunately, doesn't have any errors. And so as Obi-Wan liked to say, these are not the droids you're looking for. But this is a very common pattern in terms of debugging. We're usually trying to pull at threads to try and figure out what could the error be. Right, you'll look at logs and you'll look at all the different parameters in terms of version, version, input, instance, blah, 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 right? All those things there. So, similar to logs, like how you would log the version and all those things I was mentioning, you can put those as tags in a trace. So here we have there, oops, oh, that one's fair. Oh, that one got back. That's okay. There's a layer on the slides, but that's okay. So like one thing we're going to do, right, is we're going to try and come up with a hypothesis. Ignore the errors text in the middle. It's supposed to be more to my right, but apparently point decided to change that. But what you're going to do now is that since you have full fidelity of all the traces, when you're breaking down, you can actually break down for service or any part of your application on these tags. So what I did here is I'm trying to find out, maybe it's an environment. Maybe someone released something in development or staging or whatever, and it's particular there that's causing issues. So when I break down the currency service based on environment, I see that there are solid red everywhere. And in terms here, solid red is bad, shaded red, not so bad. And we'll get to that in a bit. But it's very much a visual cue to say, do I know if this is going wrong or not? So we know that all of these are experiencing errors, so this is not what I want to look into. There it is. Ah, yes. So next one. So what about region, right? This is another thing we can usually look into. OK, so I know that US East 1 has no issues, so OK, I'm going to eliminate that in terms of where I'm trying to debug. US West 1 has some issues. The next thing I can do is maybe just break it down within there. What I'm doing here is actually breaking down by instance, and I see that it's one particular instance that is originating all the errors. What's really cool about this is that you're actually just breaking down, this is obviously a very static screenshot thing, but you're just looking at the service and looking at different tags you've included on the trace. And so these are actually just 3-4 clicks. Versus before, or at least in terms of when I've done debugging using logs, is that I'll look for a hypothesis, query for it, and then see what the results are. And this is actually just an arbitrary tag. There's nothing special about instance or region. It's just something that's very common for most of us in terms of what we think of the most common culprit. So you can make it in terms of input, user, anything like that. So now that we actually know how to root cause, let's talk about propagating this across the system, right? So we know here that currency service was root causing errors, right? So we know that there. Now the rest of the application graph here you see is actually scoped to anything that has a dependency to currency service, so anything that interact with it in terms of upstream or downstream. So we want to find out, do the other services have any impact? So checkout service is next. And what we actually see here is that there is no root cause. So from this, we're able to say that actually the checkout service is propagating errors through across the system instead of the ones that are actually causing it. So once again, we don't need to wake these people up. Now what about the front end? The most important one, depending on who you are, but for most people. Is this one originating errors? No, it isn't. And so with tracing, drilling it in again, right? Tracing can actually tell you the difference. Front end will be paging because it is seeing a lot of errors, or it could be paging because it's seeing a lot of errors, but you actually don't need to involve the front end team anymore. Same thing with with checkout service. Now, more importantly, customer impact. How do you actually know if what you're doing or what's broken impacts anyone? With tracing, what you could do is we have this concept called workflows, where you can attach like sets of transactions to a business workflow. So for Lyft, it was requesting a ride, payments. If you have Amazon, so it could be checkout, all that there. And so with this, you can get a horizontal slice of the entire application and only see services are involved in it. And so also what this ends up doing is that when you look at the SLI for front end, you are getting what the users are seeing in terms of impact. So if they have, I can't remember what real the number is right now. Probably need better glasses. But if you know that it's a 20%, whatever that number is errors there, you know that 20% of your customers who are impacting or who are using this path are actually experiencing errors. Why this matters is that, at least for myself and my experience, and from getting to talk to a lot of companies through my time with Envoy, is that it's always really hard to connect what a service 4 hops down does and its bugs if it is actually impacting your customers. And tracing can help you do this. So I know everyone's very excited now to get tracing. I can sense everyone just like typing away. So the good thing is that there's starting to be a much better way to get telemetry and tracing. So we're saying democratizing telemetry for everyone. Open Census and Open Tracing have merged to create Open Telemetry. And what this is it actually a set of libraries, frameworks, agents, and collectors that are all agreeing upon one standard in terms of how logging, metrics, and tracing should be defined and collected. And that way, so for anyone who's adopting these, you actually only need to bring in one framework, one library, one set of collector, and you can choose whatever backend works for you. Instead of being tied to a vendor or to anyone, like maybe your own proprietary thing that you've made, you can actually have the flexibility to change any of your backends for like metrics, logs, tracing, whenever you see fit, instead of being stuck in terms of like asking your teams, hey, can you update that library, please? I know this PR has been open for 3 weeks, but please just change this library version or replace this one thing here. It does make things a lot better. What's also really cool about this is that this is actually being done by really big companies. This is no longer actually just like, say, us begging the rest of the community to join in. Google, Microsoft's involved, Lightstep, ourselves. We're some of the biggest contributors, so only in terms of fitting, they're on the slides. But many, many companies are involved in terms of making this accessible to everyone, because we just realized it's a lot of cost just to get telemetry into your applications. And it's really not worth it in terms of having to update it or change library every year or two whenever something better suits your needs. So I do recommend, please check it out. We also love contributions. Any form of contributions in terms of documentation, tiny bug fixes, those are very much welcome. So I want to say thank you, everyone, for your time. I know we're supposed to maybe doing Q&A. I don't know if they got the mics. I was also speaking quickly. But yeah, if anyone has any questions, if anyone doubts that tracing is possible, yeah. Oh.
You have a mic. Hello.
Hey.
So you said like we can ingest all the traces, but let's say I'm doing 1 million RPS or 10 million RPS for a service. The amount of trace data gets huge. And network costs in cloud is non-trivial. Like it adds up fairly quickly. Mm-hmm. I can have like a petabyte of traces in a day very easily.
Yeah.
It's a good idea to index all of that and keep it around? So
like it really is like case dependent, but so it's more like the statement of sampling should be done like was made, rightfully so, from like really, really big companies like Google, Microsoft, or anything like Amazon, and they're like billions of requests per second and all that. But a lot of people actually aren't in that size. And so part of it is like, especially if you get to like maybe a million like spans per second like that, depending on what your costs are, like maybe you don't save all of them. But maybe don't do 1%, like find something that's a little bit better. So it is definitely partially to challenge that. Don't say you need to sample right away, like depending on what your constraints are, but see if you can. Like I can't share the math in terms of what it is, but it's not as bad as people think it is. And I know like I can't give you the proof and the whiteboard proof to like show you that, but it is actually not as bad as people think it is. And so in terms like when you play around with it, if you like say do 10%, you'll actually be kind of surprised.
Okay. Follow-up question. So you said like how you can do the root cause analysis, like
Yeah.
which microservice is actually sending it. What happens sometimes is because even unrelated microservices start throwing errors because one of them is throwing errors, right? And you can't like trace that with tracing. So even if suppose service A is throwing errors and it does not talk to service B, even because service B is throwing error, it sometimes starts throwing error. So that correlation sometimes gets hard to
Yeah.
figure out. Is that something that's even possible to automate, like something with Omnition?
Maybe it's usually like, I guess like, so it depends in terms of how strict. I feel like that's a little bit in terms of people relaxing. Like I will say that I'm very traditional in terms of like what my approach is in terms of forwarding errors. So if you see one, any form of error that you deem an error, 503s are errors, everyone. Don't rewrite that to 100. But like once you see a 503, instead of like you can either have retry logic in terms of handling it and fixing that. That might be a little bit more corner case, but at least more in terms of my experience, most people tend to, like, once they have one error, just properly flush it through. It is something in terms that we definitely can adjust for and talk about. Okay. But it's mostly common case, yeah. But it also depends how strict. Like, if you're bending the rules, don't do that. Do the right way of propagating errors.
Makes sense. Thank you. Great talk.
Thank you. One more question there. There's one here. Or. Okay, I was going to also, so that way people can hear it in terms of, I'll repeat it.
What are your thoughts on carrying baggage along with traces?
Baggage.
Instead of just the time it is and the tags, but like actual baggage. So like Jaeger has a way to like attach other stuff into traces.
I think that's more dependent on how you want to use your traces. Oh yeah, the question, right? So someone, person in front of me was asking in terms of like, what are my opinions in terms of baggage? I don't know if that's the right term, but some other tracing standards have provided the ability to add extra information, metadata, or whatever you will, to your traces. I think it really depends in terms of how you use it, right? For maybe, like from what I've seen, that hasn't been necessary, but also like I've seen Lyft environment and like other customer environments, and so I haven't seen that need, but it doesn't mean that I'm right. It just means in terms of what I've seen. So I think it's really case dependent, like most things. Like if you have extra information that you really need and you don't want it as a tag, and add it. Any other questions? No? Cool. Thank you very much, everyone.